The opinions expressed are those of the participants and do not necessarily reflect the official positions of the sponsors, advertisers, or presenters. Advertising does not imply endorsement by the sponsors and presenters.
Hey guys, and welcome back to the Lighting Controls Podcast. We have another fantastic episode and guest for you today. As a matter of fact, this guest is someone who's been on the show previously. Before we jump into everything, let me just take a minute to remind everyone, today's episode is presented by the LCA, the Lighting Controls Association.
And it's financially supported by the National Association of Innovative Lighting Distributors, or NAILD. Check out our website, lightingcontrolspodcast.com. We've got all of our episodes, a merch store, a news feed, our council on lighting control startup and integration, and training opportunities if you're interested in learning more. Until then, we want a big thank you to our sponsor for this episode. We could not do it without you, MW Connect. Check them out, mwconnect.us. You may know them as McWong, but they have rebranded as MW Connect. They are still the same company, though, with over 40 years of experience in this industry, award-winning Bluetooth technology, ongoing support for all of the projects that they get involved in the U.S. and outside the U.S., and even more. I highly recommend you check out their website. Even if you're familiar with their products, they are always updating and coming out with new technology, and they're constantly getting new awards for that technology. We have interviewed a couple of people already from MW Connect about the entire company, and you should check out those episodes if you want to learn more. But really definitely recommend checking them out. They have some great application guides, explanation, descriptive information, specification, documentation, all of that good stuff. If you're looking for a good lighting control system, consider MW Connect. But let's get into this conversation. So today we have a returning guest, Bill. Bill, for those who haven't seen the episode you were in, do you mind just giving us a quick breakdown on who you are and what you do?
No, not at all. Thanks for having me again, guys. Bill Ellis, president and owner of Candela Controls, Inc., down in Winter Garden, Florida, just outside of Orlando. We are a lighting systems integrator and specialty contractor. We work in a variety of vertical markets, building lighting control systems and doing specialty lighting projects. We get to work in museums and theaters, theme parks, casinos, bridges and unusual monuments, things like that.
Well, thank you again for hopping on this. It's always fun to have returning guests because I feel like sometimes we just keep talking. We hit our time limit and we're like, man, we got to bring this person back on, right? And so, it's always nice.
So here we are.
Yeah, for sure. And I mean, it's not with any intention to continue anything specific we were talking about in the previous conversation. It's just you are definitely one of those people who are a wealth of knowledge and experience in our industry. Really great to have that resource here for our listeners. Yeah, well, and we appreciate you being so willing to participate in this because our goal really is just helping people learn about the industry, understand more about what's out there. And so, from your perspective, with lighting controls where they are right now, there's a lot of conversations about emerging technology, integration in general. What are you seeing as the big trends right now in where things are shifting? What you're seeing most commonly being requested, at least on your side of things with lighting controls?
Well, I think the industry, at least in North America, is still trying to figure some things out. There's a lot of my peers and all that are talking about the progress towards digital control. But when you look at the vast majority of projects, particularly stuff that comes across our desk, we're still doing a lot of analog, a lot of 0 to 10. And I was in a discussion with another group at one point, and I was actually the detractor to the digital control, partly because a lot of the people who have to maintain and operate these systems don't have access to the tools and the skills that they need to be able to maintain these more sophisticated systems we're installing, where with the 0 to 10, screwdriver and a multimeter, you can, and a little bit of patience, you can solve a lot of issues.
Right.
And depending on what the facility is, I think analog still has a great value to it, both from not only just the cost point, but what just what you can do with it. You look at the tunable white, which just takes the second circuit. From tunable white, you can go to circadian rhythm capabilities, things like that. But there is a lot of talk in the industry about looking at digital controls. Dolly is quite dominant over in the European market and is trying to make a better foothold here. You have the new Dolly 2, relatively new Dolly 2 standard, what it was affirmed, I think, in 2018, and here we are talking about it as the new thing.
Right.
And then it's how do we distribute these signals? Those of us that the three of us with the markets that we work in, we've been doing DMX SACN type protocols over Ethernet for a while. The Dolly 2 standard now has the capability of pushing that information over an IP-based network to where in projects that we're doing, we're seeing lighting is just another service on a network furnished by others. So we're living on a common building system network that's doing security cameras and access control and HVAC control, maybe BGM, things like that. Lighting is just another service. So that's one big trend. How do we power all this stuff? So I've done some presentations on PoE, providing power, and of course PoE is I still feel it's a big soup of acronyms, or my wife, she's got another phrase for it. It's not really a standard. I mean, there's a standard for PoE, but then how you put the rest of the pieces together. And then a thing that I think is really interesting and that I want to work on some more is the whole class 4 power, the digital power, fault managed power systems that I think will bring a lot of opportunity to our industry, because we convert from AC to DC once if we're coming off the grid, and then can distribute up. And I think there's some fascinating potential there.
And I just want to stop. I want to stop you there, because it is a fascinating subject and certainly worth giving it. Like, we could probably have multiple episodes just dedicated to discussing what that is. But do you mind just giving like a quick summary of what that is so our listeners understand? Because class 4 is a very new term, at least to lighting people.
Well, yeah, I mean, it just came in the last code. So, the 2023 code was the first time it was really introduced. But it's digital power. It's pulse width modulated power, and it is fault managed. It is monitored. You can take the cable and cut it, and as fast as you can cut it, it will shut the power off, and then you reconnect it and the power restores. But you can also, you're pushing, it's DC, you're pushing 300 plus volts DC. And on a typical circuit, you can push that in essentially a class 2 wiring plant. So it can live alongside your Cat 5 cables or your DMX cables in the same tray, same raceway, on a pair of 16 gauge cable, and go several hundred feet with that. So where it's found its big interest right now, putting in big Wi-Fi and cellular repeater systems in the stadiums and all, and not having to pull a whole bunch of new power.
And just to be clear about this, I mean, we're talking about, because most electronics inside of a building right now oftentimes already step to DC power. We're now just trying to cut that middleman out, or at least make it closer to the electrical room and have that wire run longer in the end, so that we don't have transformers all over the place.
Right. I mean, and hundreds and hundreds, if not thousands, of DC switching power supplies through the building, and the harmonics and everything. And like I said, it's a whole other topic of discussion. But you do that conversion once. I mean, they think ultimately, and a lot of other building industries need to get there, that you could power the entire building DC. But how can we do the bigger draws for HVAC motors and escalators and elevators and chillers for refrigerators in the kitchen and the stoves, and things like that? There's a lot more, but
From a lighting standpoint, yeah, or a communication standpoint.
Communication systems and all, this is a very viable way to think.
Absolutely. I mean, totally. I agree with you. I think that is definitely on the horizon, and people should be paying attention to what that is, because the idea of where you're getting your power from is going to change over time because of that. Instead of having, okay, well, where's the wall wart going to go? It's going to be, okay, where's my step down from 300 volts to 24 volts going to go?
Right. Which is a very simple thing to do at that point. There's still a lot of standards work that's being done for it. The National Electrical Code has an article in it. There are more, there are additions and changes to that article that are forthcoming, and what those of us involved with the 26 code are doing right now. But it's, I think, one of the bigger emerging markets for us. The other thing, going back to from a control standpoint, is single pair Ethernet.
Right.
It's a IEEE standard, and I think for our industry, what we're all wanting to pay attention to is the multi-drop capability. I think this is the future of, this will replace DMX in certain applications. But IEEE is still got a lot of work to do. We're an industry that doesn't have a whole lot of R&D dollars, so we're kind of waiting for the other guys, the automotive industry and people like that to figure this out. There's already an elevator manufacturer that their entire control bus runs on single pair Ethernet, and also we're starting to see some of it come into the building industries. But here you're going to be able to get a signal that's 40 times faster than DMX, runs on a single pair. Hopefully, with the multi-drop, we're going to be able to daisy chain, X number of fixtures together. There are other people who are talking about power over the multi-drop, but our power needs are much greater. But you take, say, a single pair Ethernet with our class 4 power, our fault managed power. Wow, what a game changer to the way we operate lighting. Get all that feedback. Now things like RDMnet, the monitoring that comes back on Dolly 2 and all. Hey, you've got a full-time two-way path from the fixture at a really nice speed. I mean, it's 10 megabit, but for what we need in lighting, 10 megabit is godsend. It's like, wow, what a dream. And we would still be able to use our same protocols. We'd be able to use SACN and RDMnet and all. It just changes the physical layer of how we get from point A to B. So I think that's another. There's a couple of us on committees that are waiting to see where things go, and then let's start working on the standards, how we can practically apply this to the lighting industry, because I think it's going to be a huge benefit to us in the long run.
Totally. And additionally, the more we go towards standard cabling, standard wiring formats, the easier it is, because a lot of complaints that personally I hear from contractors is when you're using non-standard connectors or non-standard cables.
Non-standard wire.
Right. Because it's either going to be incredibly expensive and they're not going to see the reason to buy it, and they're going to use a sub and it's going to be really bad, or they're just going to complain the entire time they have to run that cable.
Right. The really cool thing with some of the development in single pair Ethernet is it runs over the same RS-485 wire we've been using for DMX. It really becomes somewhat copper agnostic, if you want to look at it the way they're pushing it.
It still needs to be a twisted pair, I'm guessing.
For the type of distances we're talking and everything, it'd be a twisted pair. But the really cool thing is we could use a lot of the intent from day one with single pair Ethernet, because it came out of industrial automation first, was to use the existing wiring plants. And so they were looking at Profinet and these 1,000 and 1,500 foot runs of Profinet, which are on a single twisted pair 18 gauge. but they wanted faster speed and they wanted full two-way communication. So that gave them the impetus to start and, then let the wizards way above, well, I think what any of us are capable of, go and figure out all the math to make that work. And
I want to make sure I just realized that we also glossed over a term that might be worth defining a bit, which is single pair. Because when you're talking about Ethernet, you're often talking about Category 5 cable or some version of that, which is 4 twisted pairs. And so we're going down to one single twisted pair. You no longer need the parent version of the phone jack. You just need probably two-pin termination because you don't even have a shielding drain.
Right. There's several connectors in the industrial and the automotive market. The automotive market is the one that's really grabbed onto this because the connected systems in our vehicles nowadays are massive. Our infotainment ties to the guidance, which ties to the body control module and the engine control module and all. And CAN bus wasn't getting it done. I mean, CAN bus was a huge thing. So here they are connecting 12, 15 different devices within the vehicle on a 10 megabit full two-way network in your automobile. And then, others have gone, but we're just using a single twisted pair, depending on the speed and stuff. That's how it varies the distance. But, if I remember correctly, one of the standards, you can go from point A to point B at a 10 megabit signal up to 1,000 feet because that's what Profinet was built around.
Yeah,
and
that's awesome.
Get this incredible increase in speed and data throughput, and you didn't change your physical plant.
Right. And to compare, category cable is typically rated to about 325 feet. And so as a result, you're almost tripling your distance that you can go with this and reducing the amount of copper you're putting into that cable.
Right. And I think the big thing that I keep looking at is it's a full two-way communication stream. So, DMX is a one-way and RDM, we're trying to stick RDM in between the dead spaces of those DMX packets. So we send a request out and then hopefully there's a break somewhere and we get a response back. Well, here now we can constantly send our DMX and our RDM net can skip out there and that data comes back full time. And just now we can actively monitor, say in the theater environment, actively monitor all those moving lights in real time because we've given them a better path for all that data to flow. So
is it full or half duplex in that case with this? Does it take turns or does it communicate at the same time?
I don't remember. I'd have to go
that's fine.
dig into that a bit more. Like I said, I've been waiting for a couple other pieces of information together so I could go off and start experimenting with this and seeing where things are going. And how we can meld this in, because like I said, I really think this is the next step. DMX 512 is never going to go away. I mean, it's tried and true and robust, and just look at everything that we do with it. So it's that last. In certain places, it's going to be perfect for that last 500 feet. But as our fixtures become more and more capable, I mean, it's a matter of time that multi-parameter fixtures are going to make it into the architectural market. We do it in theater day in and day out. And museums look at some of the stuff we're doing there, but architecturally, not just changing color, but we want to change the beam. We want to focus the light. It might have a gimbal mechanism or something. And to be able to add those fixtures on and then be able to monitor them back in real time, make sure that they're performing. Hey, they need some maintenance and all. We're going to need some better transport mechanisms to make that happen. Totally. I think single pair Ethernet is definitely something we need to investigate.
Yeah, these changes and this kind of push, and including changing doing things over DC, could finally be the push for the architectural market to get away from analog too, right? I mean, half the reason that we still see all these projects analog is that it's cost based, right? For every you know, 10 analog fixtures out there, there's probably only one digital fixture, right? Like
Right.
there's from a cost basis for recess cans and troffers and everything else for your generic office, there's simply more options for analog control than digital control in the marketplace.
Correct. I mean, I think that's one of the things with Dolly, and like I said, it goes back also is look at the tools that you need to maintain the system. You can maintain a 0 to 10 system with a voltmeter.
Yep.
You get into the digital, well, you either need the custom test tool, which look at all the different options that we have in DMX that you can use on your phone or standalone and all. So I think the market will develop in time, and then these building engineers have to be able to buy that. A lot of the building engineers I talk to, don't understand why they would have their technicians, their engineers in the field have laptops. But it's like, well, if you need to reconfigure that driver, you got to have
Right.
some software and you got to have an interface to do it. And that's a hard concept for people to get over. They think, no, they just need their tool belt. Well, they're going to need more on that tool belt than just a screwdriver and a pair of pliers.
Well, and I think, this also goes into this other discussion that Ron and I keep running into, which is, should the contractors really be the ones doing that programming, or should we have this additional layer, like a third-party integrator involved? And I think, ultimately that is the direction that we're heading in. We're heading there very slowly. But groups like Candela and groups like Port, you're kind of the foundation for this, but you do kind of hover around the DMX world, whereas there's still a lot of this bread and butter 0 to 10 volt stuff that you aren't being tapped for, which I think
we're tapped more than you might think.
Well, no, for sure. But I'm saying, like, if I'm a regular lighting designer, I might not tap Candela because it's just going to be generic lighting controls, and I'm going to have the manufacturer provide the technician for that.
Oh, true. I mean, if it's, hey, we're doing some wall box controls or something like that within a room, you don't need the power of a Candela or a Port or somebody like that to come in. You are relying more on the contractor to do that. But the second, I have an electrical contractor that we've worked alongside for years, and they gave me the best analogy to it, and it was fire alarm. They went, all of a sudden they were realizing what they were seeing in lighting control and equated to the fire alarm guys. The electrical contractors are happy to do the pipe and even put the wire in the pipe. But now it's, what do you mean? I've got to get the right device in the right location, and it's got to get configured and addressed and tested and all this other stuff. And I've been hiring a specialist to do that kind of work for years. Now I'm going to hire a specialist to do the lighting whenever, and he's been a great customer of ours because he sees that on a set of drawings or whatever and goes, okay, I need to level up and the skills that I need to bring to the project. And of course, the way I always talk is, this is what we live and breathe every single day, is doing all this lighting control. And to us, it doesn't matter 0 to 10, Dolly, DMX, we work it all. And I'm here for them to be successful and for them to make money while I make money. Because if we all can get off the job site at the same time, everything runs as smooth as possible. We're always going to have our hiccups and all, but that's the ultimate goal. Why do we do this? We're here to make money, and having that specialty trade helps those contractors, those owners and stuff with that. And I thought it was a great analogy. It made perfectly good sense. We were doing a building where we were putting in just about as many control devices as the fire alarm guy was doing. Because it was all this distributed control, all the offices and all in the building, and it was perfect. It lined right up, and so it's one of those tools that I always reference.
So out of curiosity, do you see a path? Webster and I talk a lot with guests about how we integrate with building controls moving forward, where lighting control is no longer just lighting control, right? It's building control. Do you see a path forward where that also integrates with fire alarm, or would that maintain a separate entity and sort of the BMS building control would be one sort of master group and fire alarm would be separate?
I think fire alarm, just because of the way those codes are structured, because it is a life safety element. Yeah, we do have our cross points where they can signal us. But I see more and more fire alarm systems that run on cellular, that because we're gradually seeing the twisted pair analog copper phone line to the building going away. And so that market has built hardware and proven technologies that, hey, they can transmit those signals to the central station over cellular, and it's going to get through, or it's going over, it's going to analog to a voice over IP circuit, and it's going to get that way. We still traditionally in buildings, it's contact closure from fire alarm to lighting for whatever we have to do. But someday I can see it. Hey, fire alarm is running on the same network, and we're just going to route a signal. And we're just going to get an IP message that says, hey, we're in this evacuation mode, go and do this. But traditionally right now, building management, what we all think in the BMS world, we're sending information over to the BMS guys about occupancy. We're going to make that occupancy sensor in that room do double duty. It's going to turn the lighting off because the space is unoccupied, and it's going to roll the setback on the fan coil unit, so that we're keeping the room at 80 degrees instead of 76. There's other things. There's this much daylight coming in, and besides turning the lighting down or closing the shades, which is another form of lighting control that I think people forget about. We're going to take that same information and apply it to some other systems in the building. And there's nothing to say that a great example was a community college around here not only tied lighting to the building management, but also tied AV and access control. And so a teacher would swipe entry into the building. So now the system knows that they're present, knows which classroom is scheduled. So it would start pre-chilling that classroom. So HVAC gets the message, turn the temperature down. They enter the classroom. They hit the lights and it comes on. And then they had access to the AV system. So they're able to turn stuff on. The cooler thing was, class is done. Well, the system was smart enough to go, wait a minute, this teacher's teaching another class in that room right afterwards, so I'm not going to touch anything. It's all going to stay up. Or, hey, that's the end of the day for that teacher in that classroom. So besides turning off lights and rolling up the HVAC, it also made sure to turn the lamp off on the projector, because it was lamps back at that time. Now it'd be a laser. Let the fan run to cool that lamp down, and then shut the projector down and store it or raise the screen and all. And then, hey, the teacher has swiped and the classroom's locked. And so they had taken it to even a bigger extreme of tying all those systems together. Ultimate system integration, so we're all worried about our lighting world, but when you look at something like that, ultimate system integration and what you can do with this in a building.
Well, no, and I think that that's a really good example of the capabilities of good integration that we don't hear about as often. We hear more about the horror stories that are out there of, I was promised by this salesperson that this was going to work this way and it didn't work. So, hearing those success stories is really important, because that really showcases what you can do when things are integrated correctly and you have the appropriate people in charge of that design and making sure that it's done correctly.
Right. And what we in our small little world keep pushing, we all get involved at the start of a project. And what's the first thing that we ask? Well, what's the control intent? What are you trying to do here, so that we can look at not only hardware, but what are the right protocols that we should even be thinking, hey, this could be an analog, or no, it's going to need to be a digital. Well, in these type of buildings, that control intent needs to go to a bigger field. The HVAC guys have always talked about control intent, but they've got that pretty well down to a science. we have so much more flexibility in lighting. But the IES has been pushing this. There's a new recommended practice, or an updated recommended practice for control intent that's out and all. And so you talk about this ultimate system integration. Well, hey, here's the intent lighting, here's the intent in HVAC, access control, AV, and all. And then there's a central control intent that says, hey, all you guys have got to link back, and we want to see this sequence happen when this function, and so on, so that all the players that are sitting at the table know what the ultimate goal is.
Well, and those conversations, those conversations are essential. I mean, it's not just enough to have a control intent narrative and an HVAC intent narrative. Like, you really need to have the integration intent narrative, where you're talking about how are they communicating, because oftentimes you see integration with BMS and that's it, and it's like, whoa, like you're glossing over.
I can do that 4 ways.
Right. And so, are in those situations, are you ending up being the person doing that work, or who do you see does that work in the end?
Well, we typically have to go ask the questions, so we would love to be able to communicate with you, BACnet IP. Say we're going into an existing building. Well, do they have the support for that? We've walked into existing buildings and they go, yeah, the BMS system's 20 years old and all we've got are contact closures. Like, okay, so we're back to the least common denominator, but boy, it works and it's easy to troubleshoot. But we're not going to get a whole lot back and forth. It might be, hey, BMS is going to say the building is done for the day. It's 11 p.m. Sweep all the lights off. It's going to be very rude, crude type of integration. Or, are we talking about doing Modbus, or are we going to talk BACnet MSTP, or we're RS-45, where we've moved into the 80s and the 90s with this now? Or is it ultimately IP, where once again, we're on a common network? And I think a smart way to build it is we stay away from the business system. So this network doesn't have email, it doesn't have printing, doesn't do any internet access or anything like that. It's completely isolated for the building systems, your HVAC, lighting, access control, elevators and escalators, potentially fire alarm. We're all on that network. We have a path now to be able to talk and exchange this information. We're secure because, look at, and security is a big thing. Look at the incident with Target. That access was done through the building management system, because what as providers do we want? Well, if you give me remote access to your building and your building, building network, I can solve problems for you faster than I can get a guy in a vehicle rolling that way. But you've got to maintain the security over that. Hey, when nobody needs that outside connection, unplug it. The absolute safest way is air gap it. But that becomes that ultimate integration. But you've got to have an owner that can see the value in it, is willing to spend not a whole lot of money, but they're going to spend a few pennies more per the square foot to make this happen. But then they can see that value in efficiency and operations, and
not to put you on the line here, and by all means say no if you're not comfortable answering this question. But for the people out there who don't understand pricing, what would you say you're looking at? Like, let's say, for instance, you have a single floor office building, few thousand square feet, and you have a simple-ish lighting control system with some custom stuff. What are you looking at per square foot dollar value average to be part of that project?
I think that does become a bit hard to quantify, because once again, I think it goes back to that control intent.
Right.
Because, depending on what you want to do in, 8 or 10,000 square feet, you can do it very simple. You can buy gear at the local distributor. That's going to achieve a lot. You aren't necessarily going to get integration to HVAC, but maybe in a 10,000 square foot building, that's not as important.
Right.
I think, when you start stepping into the 50,000 square foot plus buildings where, hey, you're probably going to have a full-time building engineer on staff
Yeah.
because there's just, now, of course, this poor guy or lady is going to be responsible for making sure that the plumbing functions and the room stays cool and the lights turn on and, the trash gets picked up from the dumpster and, other
Right.
stuff like that.
Right.
We're going to have a lot more. But in the bigger buildings, we see that those staffs are small. Take a hotel, for example.
Mhm.
They might have one building engineer on at night, and they are literally responsible. He might be a master trade plumber, but he's also
Mhm.
responsible for making sure that, hey, there's a dead TV in this guest room that's got to get swapped out, and the lights aren't
Mhm.
working in this room, and this elevator doesn't want to stop at the 5th floor.
Right.
They get all this dumped on them, and the chief engineer for the building is looking and going, I gotta do something. I don't have, I can't keep hiring more people. That's not necessarily an efficient way. So the more tools that they're given, the more exchange
Right.
of data between these systems to allow that to happen. And we see it in the bigger hotels now. You guys, you might have run into it. Hot Sauce is like the go-to program for
Yeah.
building engineers and hotels for trouble tickets. So if there's a problem in a kitchen or in a guest room or whatever, you file a ticket in Hot Sauce.
Mhm.
And that gets it routed to the correct people. Well, we're now seeing Hot Sauce gets tied to the front desk system. And
Right.
so, hey, there's a problem with the plumbing in room 518. So front desk, don't rent out team today unless we absolutely have to.
Yeah.
So we get an opportunity to get engineering in to fix the plumbing so we can rent the room out.
Right.
Hey, it's going to flow down. We're seeing it in the higher end properties where when the front desk rents that room, the lights are turned on. There's our hook. The HVAC, gets turned on. The TV gets turned on with the welcome message. Welcome, Mr. Ellis.
Yep.
Thank you for staying with us tonight.
Totally.
All these different things start happening. So, we probably have all experienced that just in our hotels. That's just a hint
Mhm.
of what's going to come
Right.
down the road, and lighting is just another key to all that.
Totally. Yeah. And so, I mean, like when we're talking about this, I'm going to try a different approach here because I don't want
Okay.
you to be on the hook to a dollar value. But like, let's say, for instance, this hotel. Yeah, right, exactly. This hotel, you just described a decent control intent narrative there, and that lighting control system is going to cost a value. In comparison to the value of that system itself, where do you sit in relationship to that system? Like, are you half the cost? Are you twice the cost? Like, approximately, give our listeners something to latch onto, because I think it's hard for people to really visualize adding an integrator because they go, oh, it's going to add cost to this project, and they might go, oh, well, it's going to like triple the cost of the system.
It won't. So what I have found through the years, and it really depends on geographically where the project is in relation to us, because it comes down to travel cost. But
Oh,
typically
totally.
what I
Mhm.
find is our rates run to be about 25 to 30% the cost of the gear. So if it's $100,000 worth of gear, depending on the geographic location, we're typically maybe between $25,000 and $30,000 for our services, and that's a
And I
pretty
think that that's
straightforward.
reasonable. Yeah, I think, and again, like in the contrast of the entire cost of the project, I mean, if it's a brand new building, we're talking millions of dollars. Like you said,
Right.
it's pennies.
Relatively speaking, yes. And it goes back to that success.
Right.
And that success can be measured in a couple ways. We go back to our fire alarm. Well, that's life safety. There's codes and inspections and everything, and it's got to work.
Right.
You're not
Yep.
getting a certificate of occupancy. That building is no value to you without that CO. That fire
Right.
alarm's got to work. While lighting more and more, with, hey, you're trying to
Yeah.
say you're in California, you got to meet Title 24 compliance. You got to,
Yep.
you're running a building on a half watt per square foot for lighting. I mean, just think about that. Take that 10,000 square foot building, and basically you're given, help me with my math, 500 watts, half a watt per square foot, 10,000.
Right. Yeah.
10, 3 times
Math.
0.5, 5,000 watts. We're
5,000.
given half a watt per, right, half a watt. We're given 5,000 watts.
Yeah.
But, take that 5,000 watts divided by 120 volts. That's only 12 circuits.
Yeah.
It's only 12 circuits for lighting, guys. I mean, mind-boggling when, we've been filling up 96 circuit dimmer racks, and here we are
Right.
down to 12, 13 circuits to run all the lighting in this 10,000 square foot building.
Right.
But
So yeah.
you've got to get this all tied together. You've got these controls that you want to work, and hey, that lighting needs to come on to get the CO. Sure, we could cheat, disconnect it from the controls, maybe at the panel, and it's all on at full, but now it's on 24/7. No owner
Yep.
wants that, but they want to start garnering some of those savings. I want the lights to turn off when nobody's in the room. And maybe it's a simple control network, and it does tell the thermostat, hey, roll up to 80 degrees when you see the last person leave. And once again, comes back to control intent. If they are trying to do some of those more circadian things, more sophisticated things, we're getting ready to move to a new space. And so we're going to try to practice what we preach some. And one thing that I want to put in and see how it really works is circadian rhythm through the office spaces and everything. So, but cost wise, the drivers are about 20% more than if it was just a straight standard single, dimmable driver. And it's just a second pair of wires, because we're gonna do it on the analog side right now, because those are the drivers that we can get. But in the overall cost of things, it's adding maybe $1,500-$1,600 total cost for about 4,000 square
Right.
feet of office. Between the added cost on the drivers, some of the LED chips, and the wiring for it. The bigger cost, which we really haven't calculated, is going to be, programming it, actually making it do something. But the hardware costs really aren't that heavy of a lift to pull it off. And then we'll see. We'll be able to talk in a couple of years and go, hey, we have seen a difference in how our people enjoy working in the building compared to if it was just white light on all the time.
So, all right. So 2 questions. The first sort of goes back to, I lost my train of thought. I love when this happens. Where was I going? You started talking about circadian, and it brought up a whole nother thing, and I lost my entire first train of thought.
Another topic.
The first question is just out the window. It's gone.
Yep,
all right.
I'm sorry.
No, you're good. These things happen to me all the time. That's what happens when I don't.
We'll bring you back,
down.
Phil.
All right. So circadian, I'm very curious. So because there's a lot of people. Oh no, now I remember what it was. See, where full circle. The cost thing. This is why it's so tough to quantify, right? So like, you gave us a good number, and I agree with that number, but I don't want anyone to hold that number to gospel or to hold your feet to the fire, right? Because once you start getting into things like circadian and DMX and everything else, and who's addressing the fixtures, who's dealing with that. So it's just, those numbers can change, right? I think that's a good number for sort of a standard office building, none of the specialty stuff, right? I think that's helpful.
Right. We're not going to pixelmate the exterior of the building for that.
Exactly. Right. Okay. So circadian. So I'm curious. So I don't know if you get it around you, but a lot of people around here have gotten away from using circadian. Everyone's sort of migrated to the buzz term of human-centric lighting, right? And I think a lot of that comes with how difficult truly doing circadian can be, right? Because I think if you're truly doing circadian and doing it the right way, there's a lot of requirements to do that. And certainly you have the capability of doing that. But what we've found is a lot of buildings say they want circadian, but they really want more of a human-centric lighting. They want it to be warmer in the morning and then cool down and then get warmer again in the evening, but they're not necessarily as worried about following, truly the sun and this and that. So I'm curious, what is sort of your goal? Are you going to do true circadian? Are you doing more sort of human-centric focused? How is that going to all go down?
I think in the beginning, it'll probably be more the human centric. But the space will be our laboratory. We'll
Hmm.
have the sensors that we need to, because if you really think about it, yeah, it's a cloudy day. So if it's a
Right.
cloudy day, you don't want it to be bright and sunny inside.
Exactly.
It kind of blows the
Yes.
purpose. Or
Yes.
you could go, no, it is cloudy outside. I want bright and sunny inside because I want everybody to be cheery and happy.
Right.
So what do you really want there?
Yeah.
But like I said, it's we'll be in the same challenge. Get the building open, get moved,
Yep.
and then
Yep.
okay, now we have our lab space, and let's see what it really takes, so that we can really talk, to our customers and all, and go, once again, are you talking human centric or are you talking circadian? This is what's involved with that.
Yep.
We have practiced it and understand what it takes, and can better perform with it, because we aren't seeing it in specification. But
Yep.
you read the research articles and stuff on those places, and you go, hey, there might be something valuable here. And going back to your original question, cutting edge, well, that's our goal. um,
Right.
we are those experts about this stuff, and it's going to come
Yep.
up in conversation, and I want to be able to talk realistically about it. So here's my
Yeah. And I
opportunity to practice what we preach.
Yeah, and a lot of what we found, I think, is what people thought was circadian really wasn't, right? What people were
Okay.
trying to do and what their intent was didn't necessarily meet what circadian truly is, because it was exactly that. They didn't want to adjust the lights because it was a cloudy day out or it was rainy, or they weren't as worried about physical position of the sun because it's different from the spring to the fall and the winter and
Right.
how that affects the lighting in the building. So I think what we found is most people, and I think even in the hospitals, they found that they wanted to follow what the assumed curve would be, right? But more human
Right.
centric, because they weren't necessarily tracking exactly what was happening outside. And I think that's where we're
Right.
seeing that shift. And a lot of people kind of, at least here, got away from circadian and shifted to
Right.
human centric based on
Interesting.
how they were doing it. Yeah.
Well,
And
I
I think
think
it's
you got to
also
look at.
a legal thing. I think
Yes.
a lot of
Oh,
Okay.
for
people are
sure.
avoiding saying circadian because then it's a medical practice that people could say,
Yes.
well, you
Mhm.
promised circadian entrainment here
Okay.
and you didn't deliver. But regardless, I mean, we're not trying
Right.
to smack you down for saying circadian. I mean, it's
Oh
on
no.
it's
No, no.
whenever somebody
Do it.
says
Go for
human
it.
centric, I just see in my head them crossing out the word circadian and writing above it human centric. It's just like
100%.
it is the same term in every use except for the fact that it's not a legal term. But
Right.
we're
Makes
almost out
sense.
of time here, so I
Oh,
want to
yes.
wrap up what we got here because really good stuff, and definitely want to have you back on again, Bill, because again you just
Love
have
to
this
be.
well of
I do.
information and
I
just
love
throw a
talking with
bucket
you
in.
guys. Yep.
So, but yeah, I mean, as far as technology goes, I mean, we are seeing a lot of innovation and a lot of interest in digital controls. And I think that people like you and groups like Candela and Port Lighting are going to be essential to us achieving that because outside of North America, we have third party groups that make sure that installation and programming is done. Whereas inside the North American market, we still see a lot of groups that are sales groups that are doing that work. And so there's less integration and more just programming and technician work. So as we start getting into this diverse and more open standard format, whether it's Dolly 2 or it's some other protocol that takes advantage of single pair Ethernet, like you were talking about, we are going to need to have knowledgeable people as the right hand support to the contractors, because the contractors, like you said with fire alarms, they just run the conduit and the wire. They don't actually think about device placement, any capacity needs, programming functionality, all of that. So there really does need to be a group holding their hand and saying, okay, we got it. We got this part. You take care of that part.
Right.
And we just don't have that set up, at least in the commercial side of things. And so it would be really great to see more groups and more awareness and more usage. And it is really great to hear that there are contractors that are tapping you. And I know Ron's told me similar stories where contractors do buddy up with integrators now and just go, nope, this is a project that I need to grab these guys for. I'm not touching this without them. And it unfortunately does increase that price tag a little bit. But to your point, that price tag is very minimal. And in the grand scheme of things, that price tag might actually be a lot less than if they didn't hire you, because of all of the mistakes and issues that would arise from you not being a part of that project. And so getting you involved early in the process really ensures that it's going to be a smooth process. And additionally, you can stay on target with your budget, as opposed to without you involved, it could really be a lidless situation where things just keep getting more and more expensive, because it's like, well, what if we did this? What if we did that? What if we did this? And then suddenly you've just bought, an extra 50 grand of equipment you're never going to need. And so there's
and
just
unfortunately, they end up learning they end up learning the hard way, and oh, okay, that was the wrong way to do that. I'll listen to you next time. I get it. And so I love this because we had that opportunity to educate people so that they don't necessarily have to do it the wrong way the first time. Let's do it the right way the first time.
And again, it's just sort of like, yes, the price might go up slightly, at least at the forefront, but the cost of what is the cost of making a mistake versus doing it right the first time? And so that's the benefit that they get with you. And hopefully we're going to see more savvy contractors out there starting to listen and go, oh, okay, I should grab these guys. I should get them involved. I should have them do my lighting controls so I don't have to be there standing on a ladder reading an instruction guide that's not even helpful for what I'm trying to do. So because you've gone through, you test your equipment, you've done the experience, you have people who have programmed it before. So it's really critical. And to your point, it's not just digital systems. It's not just specialty applications. If it really does need somebody to be there to hover over. I mean, if I asked you to do a wall box installation for a single room, you might say it's not going to be worth it. But if I really insist, you'll probably say, sure, we'll do it. Because
if you want me to send the tech for the day, we can consider that.
Yep.
Exactly. So, I mean, it's not that you're going to say no. It's just that you're going to be realistic about the project needs. And if it is really a dummy-proof system, you're probably just going to be like, you really don't need me for that. That's it's going to be not necessary.
Yeah, we say we are not for every project. There are projects that are straightforward. That it's all commodity type controls that are coming off, and most contractors can handle that. It's when it gets up to that next tier of stuff where our value starts to come into play.
Right. Absolutely.
Awesome. Bill, thank you so much for your time again today. It's a fantastic conversation as always. And I think we'll definitely
I was taking notes too, so.
Perfect. We'll focus our next conversation after you get your building up and running, because I think everyone would love to hear how this goes. And you guys it's the perfect case study, right? We always talk about doing stuff like that here, and we never do it because of time. But you don't need to wait a month for the technician to come back out or write down a list of the things aren't working. You're gonna be like, I'm gonna fix that right now. Yeah. So I think it's great. And I think people will be very interested to hear how it goes and what you guys end up adopting and what control system you use and all that. So I think we will definitely have you back after you've got that square, and we'll go from there. But
I will.
Thank you again.
I will make sure to take every notes.
I love it. Yeah. Thank you for everything today. Again, it's a fantastic conversation. And I will wrap us up. Remind everyone Today's episode is presented by the LCA, the Lighting Controls Association.
And it's financially supported by the National Association of Innovative Lighting Distributors, or NAILD. Check out our website again, lightingcontrolspodcast.com. Got all of our episodes and a bunch of other stuff. And huge shout out and thank you to our sponsor for this episode, MW Connect. Again, they have rebranded from McWong. Check them out, mwconnect.us. Really great resource. Happy to help with your lighting control solutions if there are those solutions that you don't have an integrator involved. If you do have an integrator involved, also a great solution. They're just a really good option for those Bluetooth mesh networked lighting controls applications where you need just high quality equipment to support your project. So check them out, mwconnect.us. But until then, thank you everyone for joining us. And Bill, thank you. This was such an awesome conversation.